Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farouk from Mechanical Engineering Faculty. Today I will explain to you about the theory of high-pass filter.
A high-pass filter is a filter which passes high-frequency signals and low. In other words, high-frequency signals go through much easier and low-frequency signals have a much harder getting through, which is why it is a high-pass filter. High-pass filter can be constructed using resistor with either capacitor or inductor. A high-pass filter composed of a resistor and a capacitor is called a high-pass RC filter, and a high-pass filter with a resistor and an inductor is called a high-pass RL filter.
A high-pass filter lets through the high frequencies by cutting all the low frequencies. This can be helpful when you just need to remove a whole bunch of low frequencies from your signal, and it can be really cool as an effect. This is what it sounds like on the background music. So you could clearly hear where I cut away all the low frequencies and where I brought them back in.
Hi, my name is Muhammad Najmi bin Zamri, and I will explain a little bit about high-pass RC filter and high-pass RL filter.
So, first of all, I will explain about high-pass RC filter. A high-pass RC filter is a filter which passes through high-frequency signals composed of a resistor and capacitor. To create a high-pass RC filter, the capacitor is placed in series with the power signal entering the circuit. This is a high-pass filter. As a capacitor is a reactive device, it offers resistance to signals of different frequencies entering through it. A capacitor is a reactive device which offers very high resistance to low frequency or DC signals and low resistance to high frequency signals. As it offers very high resistance to DC signals, it blocks them from entering through, as you can see in the circuit diagram. So this type of filter only allows high frequency signals to pass through and not DC. This type of capacitor also functions as a coupling capacitor because it couples the AC signals from one part of a circuit to another by blocking the DC. And now we move to high-pass RL filter. A high-pass RL filter is a filter composed of a resistor and inductor which passes through high-frequency signals. To build a high-pass RL filter, the inductor is placed in parallel to the power source signal entering the circuit. This is high-pass RL filter. It passes through high-frequency signals. An inductor, like a capacitor, is a reactive device. Inductors offer different resistance to signal input into them of different frequencies. Inductors pass low frequency signals with very little resistance, while offering great resistance to signals of high frequency. Thus, low frequency signals passes through very easily without any attenuation, and high frequency signals are either completely blocked or greatly attenuated as output.
Hi, I'm Lawan Kumar. I will explain you about the calculation involved in high-pass filter. We have gone through what a high-pass RC filter is. So let's see the calculation involved in a RC high-pass filter. So the formula to calculate the frequency of an RC circuit is Fc equal to 1 divided by 2 pi RC. Okay, Fc is the cutoff frequency. So cutoff frequency means it's a boundary in the system's frequency response at which energy flowing through the system begins to reduce, attenuated or reflected rather than passing through the circuit. So R is the resistance and C is the capacitance. So by the formula above, we get the frequency of the circuit is 15,923 Hz, where the pi is equal to 3.14 and the resistance is equal to 1000 ohm and the capacitance is equal to 10 times to 10 to the power of -9 farad. Therefore, the RC circuit will pass frequencies above 15,923 Hz with barely no attenuation. Frequency below 15,923 Hz will be attenuated. The further away and lower it is from 15,923 Hz, the greater the output signal is attenuated. The diagram showing what happens to the low and high frequency when fed into this high pass filter. So the low frequency signals near 0 Hz are blocked and do not go past the capacitor. Therefore, the signals do not show up an output. The high frequency go through unimpeded pass to output. This is what it is a high pass filter. It passes through high frequency but block low frequencies. Okay, now let's see the calculation involved in a RL high pass filter. For this circuit, we use a 470 mH inductor and a 10 kilo ohm resistor with the following circuit configuration. The circuit will form a high pass filter passing through high frequency signals through to output while filtering low frequency signals through the inductor. Since the formula for high pass RL filter is FC, cutoff frequency, equal to R divided by 2 pi L. R is the resistance and L is the induction. So by using this formula, we get the cutoff frequency of this RL high pass filter is 3.39 kHz. This means all frequency above 3.39 kHz will be passed through without attenuation, while frequency below this value will begin to get attenuated. As you get lower and lower and further away from 3.39 kHz, there is a greater attenuation as the frequency goes down.
My name is Saravanan. From the group we discuss about high pass filters, and now I discuss about the application of high pass filters. High pass filters mostly used in audio system which has high frequency to a filter which emitting both signals which could interfere with or damage the speaker. And secondly, we can think about the high pass filter are also used in digital image processing to perform image modification, enhancement and noise reduction and etc. etc.
Sometimes, the best way to give something in a mix more power and more energy is to take energy and power away from other mix elements. Take for example this kick. It sounds really good on its own, it's very sharp and defined, but the minute I re-enter it into the mix by unsoloing, it's competing with all kinds of other energy, especially low-end energy coming from other elements in this mix. To give more power to my kick, I'm going to take low-end energy away from other mix elements, and I can do it super easily by going over to my kick, opening up my neutron, and I have neutrons and mix taps scattered all over the tracks in this session, which means I can go to my masking meter, take a look at what's happening on my bass, and make some EQ moves. So I can see that we have a little bit of masking here coming from the bass and the kick. So I'm going to take energy away from the bass. I'll right click to choose a steeper slope. I'll do a high pass. I'll do the same thing for the main drum. Up the sensitivity meter. So it's showing me a little bit of masking over here. Turn on that high pass filter again. Shave off a little bit of energy from those drums. Not so much that they disappear.
A high pass filter to sharpen your images. So we have this image I shot from an engagement session. Just a little detail shot of the ring, and it's a pretty good focus. It's not like tack sharp, but it's good enough. So let's sharpen this sucker. What we're going to do is we're going to hit Control J, and that's going to duplicate our background layer into a new layer. And we're going to go Filter, Other, High Pass. Now that's going to give us this little menu, and it really only has one thing we can change, and that's radius. And that's going to be the amount we sharpen. Now as we go up, it's going to get sharper. You can kind of see it's going to get kind of weird looking. So normally I live somewhere in the 0.9 range to about the 1.9 or 2 range. With detail shots you can get away with a little more, other times not so much. So we're going to hit OK, and we're going to go Overlay. And that is pretty much it. So as you can see, turn it off here, back on. it makes a noticeable difference and it looks quite a bit nicer.